For our next example, we have two rational expressions that we're asked to subtract. And in this case, we do not have a common denominator once again. Now, my denominator on the left is a trinomial, x squared plus 5x plus 4. Denominator on the right is simply x plus 4. Now, I could have a common multiple if I simply multiply the binomial times the trinomial, but that would give me a pretty large expression that I don't think I want to deal with. So what I will try to do is to break down this larger polynomial that I have here into factors to see if maybe it shares a common factor that I already see over here in x plus 4. Well, if I factor x squared plus 5x plus 4, I can rewrite that as x plus 1 times x plus 4. And if you're not sure about how to get that, you could always use the British method and work your way to that answer. Seeing as I have x plus 1 times x plus 4 as a denominator of this fraction, the least common multiple then between this denominator and that denominator will be the product x plus 1 times x plus 4. I already have x plus 4 as a factor here. I don't have to use it twice because it's a shared factor. That being the case, my common denominator will be what you see here, x plus 1 times x plus 4. I'll write that over here. Whatever we have when we're done will be over x plus 1 times x plus 4. So now I have to think about how do I change each of these fractions so that it has that for a denominator. Well, the one on the left already has that denominator and simply needs to just stay as 3 for our numerator. So I'm not going to touch this, I'll just leave it as a 3. The expression on the right has x plus 4 for a factor already. It's missing, however, the factor x plus 1. That being the case, we'll multiply both numerator and denominator by x plus 1. My denominator has the two factors that I need. It's all set. My numerator, I will distribute the 4, and that will give me 4x plus 4. Now be careful here because, again, this is subtraction. So when I write this over here on the right above my common denominator, I'm going to write 3, which didn't change, minus, and then I'm going to write the next expression in parentheses to remind myself that I am subtracting not just one, but two terms. So in parentheses, 4 times x, which is 4x, and 4 times 1, which is 4. Having it in parentheses reminds me that, hey, I'm not just subtracting the first term, but I'm also subtracting the second term. I will distribute the negative sign to do that, which will give me 3 minus 4x minus 4, all over my common denominator still. Now I can add like terms together. 3 minus 4 will go together to become negative 1. The negative 4x will stay as is. So I'll have negative 4x minus 1. That will be my numerator, all over the common denominator x plus 1 times x plus 4. Not seeing anything I could factor here? Well, maybe. Can I cancel the 4's? No, because this is part of a sum and not a product. Can I cancel the 1's? No, this is part of a sum and not a product. So, that being said, there is our final expression.